Now, the next topic that we will discuss is distance between parallel lines. What are parallel lines? Parallel lines are the lines, the distance between them remains constant, that is, the distance between them throughout remains constant. That is, the perpendicular distance between them throughout remains constant. Now, since lines are parallel, let us assume that the lines are ax plus by plus c1 is 0 and ax plus by plus c2 is 0. We have already discussed that if lines are parallel, then their slopes are equal and their xy part remains same. The only difference comes when it comes to the constant part. The constant part would be different, the xy portion will remain same. Now we are interested in finding out this perpendicular distance between these two lines. So the process is, what we'll do is we'll find any point on any of the lines. Let's say we have found out this point. Let this be an arbitrary point on the line this, and what we will do, we will find the perpendicular distance from this point on this line. We have already discussed how we can find the perpendicular distance of a point from a line. So obviously this line will cut, the most obvious point would be any point on the x-axis or y-axis, because this line will definitely cut the x-axis or y-axis somewhere. So for example, if we take the arbitrary point to be a point on x-axis. So a point on x-axis is a point where y is 0. So we put y equals to 0 in the equation. What do we get? Ax plus c1 is 0. That is, x is minus c1 upon a. Therefore the point on x-axis is minus c1 upon a comma 0. So now we have assumed this point to be, let's say, minus c1 upon a comma 0. And we know how to find the perpendicular distance of a point from a given line. So what we'll do is ax plus by plus c2, we'll bring all the terms to one side, divide by coefficient of x square plus coefficient of y square and take square root, take mod and substitute the value of x as minus c1 upon a and substitute the value of y as 0. This will give us the perpendicular distance. Let's say this is p. This will give us the perpendicular distance between this point and the line, and this perpendicular distance will be same throughout because the lines are parallel. Therefore the perpendicular distance between these lines will remain the same. Therefore this is minus c1 upon a into a plus c2 divided by a square plus b square. A and a goes. Therefore we are just left with c2 minus c1 upon under root a square plus b square. So the method that we will follow is, we won't prove this every time. What we have to do is make sure all the terms are on one side in both equations to avoid any problem. Or if you don't want to do this, c1 and c2 should be on the same side, at least c1 and c2 should be on same side. Should be on same side, either on the left hand side or on the right hand side. This should not be the case that c1 is on the left side, c2 is on the right side and vice versa. Both of them should be on the same side, and then just see what c1 c2 values are and put this in the formula. A and b will be same for both the equations. Therefore we can simply find the distance between the parallel lines. For example, let's take an example. Let's take a question on this. Let's say we have to find the perpendicular distance between the lines. Find distance between the lines. The question won't tell you that the lines are parallel. You will have to understand that the lines are parallel or not. And 6x minus 8y minus 15 is 0. Now if you look closely, these two lines are parallel, because if you take 2 common in the second equation, we have 3x minus 4y minus 15 by 2 equals to 0. Now the xy part is same in both the equations, therefore the lines are parallel, and therefore the distance between them would be simply c1 minus c2 or c2 minus c1 upon a square plus b square. Now what is c1? First of all, make sure that c1 c2 are on the same side, and therefore they are. Therefore c1 is, let's say, plus 9 and c2 is minus 15 by 2. What is A? 3, and what is B? 4. Therefore, we'll put this in the formula. C1 is, let's say, 9 minus 15 by 2 whole divided by 3 square plus 4 square under root. This is 9 2s are 18 plus 15 upon 2 into 5. This is 33 by 10 units. Therefore, the distance between the lines is 33 by 10 units.